Good afternoon, my name is Richard Chrysler and I'm here to talk to you about the 700 series experiments for the Process Control Lab, Process Dynamics. So this is experiment 2 and we're going to be working with some new equipment, and I want to make sure everybody's clear on how they're going to be working with this equipment during the lab. So this is 710, experiment 710. There's an absolutely identical unit, this RT030 from Gunt, over here. So this is 720. So if you're 710, you're assigned to experiment 710, you'll start here. And if you're assigned to experiment 20, you'll start here. However, there is a wrinkle to that. You're also going to use another apparatus, which I'm going to show you over here. And if you're the team assigned to experiment 710, you're also going to work with this apparatus over here for the first hour and a half. Okay? So the first hour and a half, if you're assigned to experiment 710, one student will be over there with the Gunt apparatus. The other student will be over here working with this apparatus. You can switch up if you want, however you want to do it, that's up to the team leader. But regardless, both teams that are doing 710 and 720 will work partly with the Gunt unit and partly with this unit. So if you're 720, experiment 720, you're going to work with it the second hour and a half. Okay? And so you can look at the videos for the process measurement and kind of get an understanding of what's involved with this particular system. But basically what we're going to do is we're going to control the pressure inside this tank with a controller in what's called a closed loop, so a feedback control system. So this is an electronic pressure regulator. The controller will send a signal to it, and the regulator will adjust the pressure based on the input signal. Now the controller gets its information on what to do from a configuration file. So on the computer, we have this configuration file for the controller that you had some experience with during the process measurement lab, and I want to expand your knowledge and your experience working with this software on this experiment, which is one of the reasons why I want you to work with this apparatus. And the other reason why I want you to work with this apparatus is because this is more like a real system that you might set up when you're at work, in the sense that you'll have to specify a system, all the components of that system. You'll have to put it all together, program the controller, and get it to work. And so this is more like real life. The Gunt experiments, or the Gunt apparatus that we're going to talk about later, they're really good for what they're designed to do, but they have limitations on your ability to understand how all the components work together, how to select the right components to do the job you needed to do. And so this is a little bit more realistic to what you'll be doing. So what we're going to do in this experiment is we're going to do a series of experiments where you're adjusting the proportional band. You're going to also induce, say, a disturbance in the system and see the effect that it has and the response of the system to that disturbance to get back to the set point value or not get back to the set point value depending on how it's programmed. Now what I'm going to do is, over the weekend, I'm going to put a quick opening valve here. So this will be set probably somewhere around 50–60%, some disturbance value. And to get the disturbance, you just got to quickly open that, and then that'll be it. So it'll be set, and then you can see how the controller responds. Now one issue with this particular apparatus is that currently it's not configured to send data to the computer. So what you're going to have to do is either record data by hand using a timer and a piece of paper, or if you have a phone that takes videos, you can videotape the input measurement change with time as you conduct the experiment. And when you read the instructions that I'm going to post this weekend for this experiment, it will be clear in terms of what you're going to change in what order and what constitutes a complete trial. So I don't want to talk about the specifics on that. I'm going to make it very clear when I type up the instructions, and you'll be able to understand what to do. But essentially what you'll do is you'll make changes to your configuration file. And then once you make those changes, you'll then need to send that information to the controller, and you'll do that by clicking on the right button, and you look for the serial port. And once you click that, what it's going to do, it's going to prompt you, are you sure you want to do this? And you just say, yes, 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 I'm sure I want to do it. And we're going to give you ranges of values. So this one uses proportional band. The other system uses gain. And so we'll give you a range of those values to use. We may even give you some specific values to use because we know that they will give you the data that you need. But it's also about doing a little bit of exploration as well. So we're going to try to build everything in there so you'll have some fixed values that you'll be able to get some really quality data with that you can analyze, but then also, provided you have enough time, experiment with some other values as well. And depending on whether you're just changing the proportional band, the proportional and integral settings, or if you're changing the set point or introducing a disturbance, you'll see different effects on that. So let's go over here and talk about the gut unit. And so this unit has a little air compressor that pressurizes this phase. And you have a pressure gauge, an analog pressure gauge on top, plus you have a pressure transducer that's also measuring the pressure of this vessel. And you also have a solenoid valve that can be opened or closed to introduce a disturbance. So the nice thing about this system is you have a software package already written for you that will save data to Excel. But there's a way that you have to open up the data, and I'll show you how to do that here in a second. But when you come in the lab, this system will be set up and it will be at some steady state. Okay, it'll be at some steady state. And then what you'll do for your first trial is you'll change most likely just the proportional gain. So let's change that and observe the response of the system. We'll change it. And so depending on what settings you use, you'll see a bigger change or a smaller change. And you may have a very stable measured value, or it may oscillate just depending on what settings you have. And so as long as you see this pause button here, that means it's actually recording data. And if you press the pause button, it will stop collecting data. And so if I click on this and stop, and then I go to Save Graph, I'm going to type in some name, S2, okay. And I would recommend saving these data either on a folder you create yourself on the desktop, or just save it to the desktop and then copy it and put it on your flash drive, so that just in case something happens with the data file, we can that you take home with you, you still have access to your data. Oh, sorry. I didn't use the right folder. There we go. Okay. And so once it does that, you can click on it. Try to open it, say open with, or use Excel to open it. And it's going to give you this message saying, yes, I want to open it anyways, it's okay. And there you go. So it opens up to Excel. And so you have the time, you have the set point, you have the measured value, you have the controller output, and then you have the disturbance. So this Z parameter, that's the disturbance variable I was telling you about. And so to turn that on, you just press that button. And then what will happen is with the disturbance effect, you'll reach some new steady state. And depending on the, I'm sorry, let's clear the graph, start over again. There we go, now we can see what happens. So don't fool yourself like I just did. And basically the thing to do is before you make a change, I like to click clear graph and then make sure that you see the pause button there so that it is actually recording data. Okay? Then you can pulse the disturbance off just like that and see the response to that. So again, what we're going to do is we're going to kind of give you a range of these values to use. In some cases, we may even give you specific values we want you to use because we know that it will generate the data that you need. And similarly, with the other apparatus over here, when you come into the lab, it will already be at some steady state, and then you will move from that steady state to a new steady state by changing either proportional band, integral setting, introducing a disturbance, or changing the set point. And like I said, when I type up the instructions, it'll be very clear to you what you have to change in what order and what constitutes a complete trial. Thank you very much, and good luck on experiment 2.